In this video, we'll introduce a different type of neural network for natural language processing, known as a recursive neural network. So here we'll start interesting ourselves with the problem of learning representations, but not just for single words, but also for multiple words, say phrases or sentences. Specifically, we'd like to be able to learn a representation of phrases of essentially arbitrary length. So for instance, could we model the relationship between individual words and multi-word expressions which are equivalent? For instance, could we have a model that learns a representation for the word consider and also can output a vector representation of the phrase take into account, which is similar to that of consider, because effectively to consider or to take into account is essentially the same thing. They're related, essentially synonyms with respect to each other. So could we learn representation with a model learning representation for arbitrary length phrases that allows us to compare full sentences and that actually is able to maintain as much information about its semantic meaning? So for instance, a model that would output a vector representation for the sentence word representations were learned from a corpus that would be very close to an equivalent sentence which says we train word representations on a text data set. So that's the question we're going to be interested in trying to address. See how well we could learn a fixed size representation of these fairly long sentences and still maintain as much semantic information as possible. So to tackle this problem, Richard Socher and his colleagues introduced a different type of neural network, which they call a recursive neural network. So I'll first describe the general idea. In the next videos, we'll look at the different components and how they work. So what they propose to do, if we had a sentence, say a small crowd quietly enters the historic church, then to get a representation of the full sentence, they would first take the sentence and extract from it a syntactic tree, a binary syntactic tree, which essentially identifies the internal syntactic structure of the sentence. So I'm not going to say much about what syntactic trees are, but essentially we have data sets that identify for different training sentences what is the syntactic tree, and we're able to train models for performing that, and actually we'll be able to use a recursive neural network for performing that task. But essentially what the syntactic tree gives you is that it identifies essentially the meaningful phrases within the sentence and how they relate with each other. So the syntactic tree here is saying that there's a sentence which is composed of a noun phrase and then the verb phrase, where the noun phrase covers a small crowd. So normally here there'd be a bigger tree, but since we don't have enough space, you should imagine that there would be a small tree here. And so that forms a noun phrase, and then we have a verb phrase which essentially covers all of these words here. And this verb phrase is actually a smaller verb phrase covering quietly enters, and followed by a noun phrase, which is probably the object of quietly enters. And this noun phrase covers the historic church. And this noun phrase is actually a determinant followed by a smaller noun phrase, and this smaller noun phrase is an adjective followed by a noun, specifically historic following church. So that's the kind of information that is contained in these binary syntactic trees. And now to get a representation, a vector representation of the full sentence, the idea in recursive neural net is to recursively merge pairs of representations of smaller segments to get representations that cover bigger segments. Specifically, we'd start with the word representations themselves, and then going up in the tree, we will take the two parents of a node and merge their representations using a neural net which will take as argument the two representations and output a new merged representation. So for instance, the first thing it could do is take the word representation of the word historic and then the vector representation of the word church, feed that to a neural network, which would then output a new vector, which would be use as the representation for the noun phrase historic church. And then to get the representation at that level here, the vector representation, then we'd merge the representation of its two children, that is the word the and then the noun phrase for which we just computed its merge representation. So then we'd feed to the same neural net this vector, and then it would output the vector representation at that level. And we continue like this for each node in the syntactic tree until we reach the root, and that vector would be considered in our model as the vector representation of the full sentence. So what we need to specify at this point is what shape will take this model that merges pairs of representations, and also how are we going to model actually the tree structure, and specifically how are we going to extract this tree structure from the sentences. And these are the things we're going to discuss in the following videos.